Hello everybody, I'm Alexy Khrabrov, the organizer of SF Scala, and here we are on location at Radius Intelligence for tonight's meetup devoted to protocol buffers. It's a very exciting topic. We all love our data. We all love serialization. We have two talks with David Yu and Nadav Samet. And here we have Nadav Samet with us. Hi Nadav.
Hi, nice to meet you.
So Nadav is the CTO and co-founder of TrueAccord, a startup which is using Scala, and I'll let Nadav tell us about it in his own words. So what is TrueAccord and how is it using Scala?
TrueAccord is fixing a broken industry, the debt collection industry. Right now, a lot of relationships between merchants and customers are being broken by the debt collection process. If a customer owes you money and you send him today to a traditional collection agency, you know that most chances that he will be treated badly, and we're trying to transform the debt collection industry. We've built using machine learning and behavioral analytics algorithms that would classify the customer. We'll know what the customer is about, infer the primary objection, why the customer is not paying, and based on that, we'll try to engage him in communication with our system. So we'll send him an email, and the content would be using the tone of voice, the language that would resonate with that customer and get him to talk to us. When he's in our platform, we'll try to get him to negotiate with us on a settlement and eventually resolve the issue. And all of that with low touch, no call centers, no aggressive phone calls. Everything is a 21st century experience, online, very, very advanced.
I mean, that sounds really exciting. I think a lot of folks, were students and had debts and have experience with collectors, and US is a lot driven by debt, so that seems like a very important subject. I'm very actually interested in this because you mentioned machine learning and data mining, and that's an area where Scala is often used because of various data mining tools available on the JVM platform. So maybe you can talk a little bit about why Scala and what kind of data mining are you guys doing there?
Yes. So when we get an account into our system tries to classify it and figure out what this person is about. Is it an individual? Is it a business? If it's a business, what is the business up and running, or is it a business that is about to fail? And all of that is based on data that's online. So for example, if you start with an email address and you see mike77@gmail.com, you'd guess it's an individual. But if you see an email that looks like a first name dot last name at company.com, you can go to the company website. Can you go to find that company and see who are the people who work on that company, and you can tell this person is associated with the company or not, how the company is doing, and so on. So we do a lot of data mining to extract features about every account and use our base our engagement strategy based on that account. And we do it in a very reactive way. So our system is always looking at those accounts. It's looking always at our logs. We're streaming the logs to a decision server. And all of that is based on akka. There's an actor system that is doing that. It gets basically we send to a decision making. Every action that happens on the system, every page view, every email can trigger decision making. We make right now 1 million decisions every day. And we constantly look at the decisions the system is making and monitor the results of them to make sure that we tune our algorithms and we improve the recovery rate for our customers. So this is basically what happens. We are extracting data that we can find on public sources, get it to analysis and decision making, acting on that, filtering through compliance checks because we are a very regulated industry, and then monitoring the decisions that we are making.
So you mentioned tone of voice. Do you analyze actually phone conversations and tone of voice, or do you make recommendations in general? How does that work?
So when we know about a person, if he's a young American male, we learn that we can speak to him maybe with a sport metaphors, and that would resonate to him. In contrast, if it's an older business guy, we might use a different way to discuss the matter with him, or with a stay-at-home mom, we'll use different language and different words. You'd use different triggers to talk to them, and this is where the behavioral analytics is coming in. So when I say the tone of voice, I refer to the way the emails look, the colors, the language, and the general look and feel of our website changes based on the messaging and on the person.
This is very interesting. So to a young guy, you can speak like a parent,
Yes.
right? And so it's an older person who can speak like a friend, and so the persuasion strategy would differ. That's really, really interesting. So how much of natural language processing do you plan to do? Because it sounds like you want to understand the conversations themselves.
Yep. So we don't do natural language processing yet. I think it's going to come. I'm looking at the emails we're getting, and a lot of them look the same, and I have thoughts about, oh, I can actually generalize this. I can recognize these keywords they're repeating, and I can infer something from them. Right now, we have humans that actually read the emails. We have right now one email per 15,000 customers. Sorry, one customer service person per 15,000 debtors on the system. Or in the industry, you usually find one per 800. So we're definitely doing something with more automation that's more scalable. We're totally changing the cost structure of this business. But to your question, we don't do email or natural language processing yet, but this is on our radar for next year.
Yeah, that's, that resonates with another conference we've done recently called Text by the Bay, where multiple companies are coming to basically understand natural language, spoken or written. And I think there is a lot of parallels I see, for instance, Zendesk, right? Companies like that receive a lot of help, support requests, right? They're compelled to understand some generalities. So that sounds like also another case where Scala has some good libraries. So why Scala, right? It's not a typical choice for data mining. I mean, it's our favorite choice, of course, but I wonder, how did you guys come to that technology?
So we started with Python. And Python is a language that I used for many years, and I still love. But at some point, we went to realization, as the system grew and got more complicated, that it doesn't work when the team grows. So for example, you create a function that takes a phone number, and now you need to know, is it a phone number inside an object, or is it a string that represents the phone number? How do you know? So you have to write a lot of test cases just to make sure the program doesn't crash in production.
Yes.
But most important than that is that people that read your code can't really tell without reading every line of the function to get some hints about what he's expecting to get. And we figured out that there is some cost when you use language like Scala. I've been using Scala since 2011. And there's some productivity cost when you have a type system. It slows you down by 10%. But you get the leverage out of that when the compiler can actually tell checks for things that common bugs, and you have much stronger guarantees about the correctness of your program when you ship it, that it pays for itself.
Yes, yes. No, that's a great. I think it's a great strength of Scala, right? That automates a lot of these cases. I wonder about your data mining. Which libraries do you guys find useful? What do you use for storage? So you mentioned you use Akka. How do you persist all this volume of information? Okay,
so a lot of the data mining today is actually still in Python in our system. We use protocol buffers to represent our data, and we store that data we use MySQL in a very interesting way. We use MySQL as a key value store, where we serialize the protocol buffers into it.
Okay.
It's an approach that was inspired by an article that FriendFeed was putting together back in 2009. So coming from Google and bringing a lot of of ideas on how to do things, I really missed Bigtable. At the same time, I didn't want to go through all the complicated or let's say adventurous tools to store my data. We are working with financial institutions, we work with banks.
Right.
I didn't want to go on something that we might not understand well enough and will cause us problems down the road. So I want something solid like MySQL. And it's been working very, very well for us, this approach. You basically get a very robust key value store.
Yes.
MySQL is way more than that, of course, but it giving you a lot of advantages in the way you can get and store and retrieve data very efficiently.
And all the ecosystem around it, like replication, right? Like there is a lot of tools around that. It's actually very interesting because when I was at Amazon, we used Oracle for money. It's like open source for everything, but Oracle for money. And I noticed that actually is a pretty common pattern because Oracle comes with all this compliance guarantees surrounding it. And so I wonder, because why didn't you guys pick Oracle? Because that's kind of what people use for transactions about money. And you have MySQL there.
Yes. So that's actually an excellent question. I came with a lot of years of using MySQL, so I wanted to use something that I already know and like. At the same time, I wanted something that would help us, more understood in the startup community. There are more tooling for it. And we wanted to use RDS, where we can actually have Amazon run the server for us. And Amazon gives us a lot of things for free when we use MySQL. So I don't need to have like our own team running the database. We get the backups, we get the encryption, we get a lot of things for free, and multiple availability zones, fallbacks, standby servers, all of that. So it's a huge advantage of using MySQL.
Nice. No, I see. That's a very good use case for RDS actually. And kind of, I assume that every event is an individual collection event. It's like it's not like you really have big data yet, right? But you need to care about every event. Right?
Yes, we cannot lose an event in our system.
Right.
It's financial data. It's something that we know. We work with banks, and we have they have very high expectations of how you treat your data, how much you care about privacy, where it is stored, who can access it. It's something that we really take seriously.
So you mentioned your Google background. Maybe you can sort of outline your kind of technology trajectory from Israel. And another question I'm very interested in, there is a lot of advanced Israeli startups which kind of, start in Israel, they move to the Bay Area very often. Like, what is it about the different culture, maybe if you can generalize, about Israeli startups? Like, why are they kind of focused on advanced technology? Is there any difference with what you see in general in Bay Area? Coming from the background.
I think it's an excellent question, and I think nobody knows the answer for real. So, I mean, I'll give you my take on it.
Yes.
And, Israel is under very special circumstances all the time.
Yes.
And I think people there learned how to deal with pressure that you usually find in startups. You need to justify your existence all the time, so you need to be very, very innovative about the things you do. And you need to be able to code under fire. So that's, I think, why there are so many startups, and there's a lot of things that attract startups here, because there are already startups. It's a magnet point for more. For us, a lot of the companies that we serve and are based here. Our favorite customers are companies who have like internet-borne debt, and these would usually be companies that are around here with clients here around the US.
Yeah, and that's because it's already online. They're looking for innovation, right? Like they're looking for partners like you.
Yes, it doesn't make sense for those companies to move the experience back to offline, to a traditional collection agency, deal with phone calls, with checks, and all of that.
Right, and they already have the data in some format, right? So, which brings us to the protocol buffers, which, as I understand, kind of, I heard that folks from Google are kind of bound to recreate Google everywhere they go. So they want to build everything. So it sounds like protocol buffers is one of these things, but it's there are multiple options available now. There's Avro, there is protocol buffers, Cryo, and Scala. So there are different serializations, and it's a big problem for JVM. It's bad at serializing things. Like it's slow, it's not C. So I'm just wondering, like, why protocol buffers? And you really did a lot of interesting work there. Using macros. Like this is like really something which Avro does not have. ScalaPB has no equivalent in Avro. For Avro. So why protocol buffers? Like why do you store all the data in them? What is it about them that kind of made you write ScalaPB?
Sure. So when you leave Google and start a company, you suddenly figure out that you're on your own. There's a lot of libraries that you used for years, like protocol buffers.
Yes.
And you are out of like all the tools, and you're a little bit on your own to build your development tools, to choose the libraries. And then you try to figure out what Google already open sourced that I can actually use and leverage, that I already know all the ins and outs of it, and that I can just leverage and be productive on day one. Protocol buffers was one of them for me. And we landed on, we started with Python, like I said before, and we have protocol buffer bindings for Python. As we moved to Scala, we use the Java version that Google provides for protocol buffers. And on day one, the Java and Python implementation could already talk to each other because it's the same binary format.
Yes.
So we could actually build a system, and users would not feel the glue that we have between those things. It would just like forward requests. If we didn't implement the request in Scala yet, and we had a Python implementation, it would just send it to the Python server as protocol buffers get it back. Everything just worked like magic. At some point, and this is I'll touch in the talk today, the Java protocol buffers were a little bit frustrating for us as Scala users. A lot of builders, a lot of mutable stuff.
Yes.
And we wanted to make something that is more functional, more idiomatic in Scala. And this is how ScalaPB came to be.
Cool. Yeah. That we also, kind of a bit of background how we, at Scala found about it. So actually at Nitro we're looking for a big data serialization format, and we actually, as many people were looking for ever and protocol buffers. And so ScalaPB was one of the huge arguments in favor of protocol buffers. But in the big data world, Avro is actually gaining the momentum. So we ended up using Avro, but now we have a task. We need to write something on ScalaPB for Avro, right? Because people who looked at it said, this is so nice. It even has lenses. So they really kind of wanted to use it just for the ease of access from Scala, because for Scala people it's very important that there is an idiomatic way to access it, right? And Avro does not have it, and then it have all this tons and tons of Java, right? Nobody wants to look at. So, but that's interesting. So, but this is a serialization format, right? So why not JSON, for instance, right? Like, why did you have to use? Because Google has big data, right? So it sends data all the time. So you don't have this volume of data yet. Why did you need to serialize it anyways?
Yes. So there are a lot of reasons to use protocol buffers over JSON, and JSON are great and they have their place, but inside your company, it's a very good idea to use protocol buffers. One of the advantages is that you define your schema in a file, and that file serves as documentation of your data format. So let's say you have a person has a first name. The first name must be a string.
Yes.
You send it to another person in a different team in your company, and they can say, this is what I expect. This is the list I have of fields. These are the types. And you know that you can set up type-safe communication between different teams in the company, as well as the file that documents all the data structure, and this is very advantageous. And at the same time, those protocol buffers support schema evolution. So you can define fields as optional, you can remove them, add more optional fields later, and the parsers and the serializers evolve, and you can have different components of the system running different compiled versions of the same protocol buffers, and they can still talk to each other, and in a very, very efficient way. So this is one of the advantages.
So this is data evolution strategy, right? You can have all the new data and still be compatible.
Yeah.
Cool. And we have, of course, I think for legal reasons, like you need to have data integrity, right? So this adds an extra layer there. Cool. So you mentioned that your company is growing, and I'm just wondering, how does the engineering culture evolve around Scala? What do you find, when the team grows, right? You made some initial choices. By the way, how did you choose Scala in the first place?
Yes. So I've been doing Scala since 2011, and we looked for something that can run on the JVM and leverage the huge plethora of available open source libraries.
Yes.
And I didn't want to do Java at the same time.
Yes.
For a lot of reasons. We're in a Scala meetup today, so there's
That's
obviously
right.
a preference for Scala.
That's right.
And I decided that it would be possible to build a team here of stellar engineers, all of them doing Scala. And I think that in this industry, you'd find that there's some self-selection in people who actually get interested in Scala. So usually most people don't have a Scala job yet.
Yes.
But if they bothered to learn Scala, or they got interested, or they opened the book, or they watched a video, that makes them very, very good fit, or the type of engineers that we want to hire. We want to hire the people that have passion for technology, and they want to learn new things and work on real world business problem that is really, really ripe for a solution. I
think it's a really good situation for Scala. But how do you see your culture? So you are a Scala enthusiast, and I'm a Scala enthusiast. We kind of know what we like about Scala, but probably as you grow, right, you will probably get some people who are not necessarily as enthusiastic as us, right? Like maybe they're not there yet. Maybe they heard about Scala, right? So I wonder, how do you see the culture evolving as your team grows?
Yes, so I really would like to grow our team around Scala. There are a lot of stuff that we are doing with Scala. We have another team in the company that does Python for a lot of the analysis and the business intelligence part of our system. But as we grow, we really spend a lot of time thinking about how we're using Scala, what libraries we're using, and what parts of what we're doing is actually general enough. We are building basically something like a marketing system that is focused on that collection, right? So a lot of things of the strategy we're using about marketing, and a lot of problems that we solve can actually be applied to different businesses, different industries. So we all think, how can we grow and also have a more open source projects that we can get out?
This is great. I think this is a great model, and actually this Scala Python interaction is something we're gonna address in August. We have the conference called Big Data Scala, and there are two themes: end-to-end pipelines in Scala and data science on the JVM. And we're looking for folks who use both. So this is great that we found a company like this, right? Because our goal is to bring as many people as possible from Python onto the JVM. And for that, we kind of need to map out what are the missing pieces, right? Like what are the gaps? We have some linear algebra tools. We have excellent data mining and machine learning, right? But some things are still missing. Some things Python people dearly love, like pandas and scikit and things like that, right? So it's very interesting to see how you guys will evolve. Next year we should definitely check in again. And so I will wrap up with kind of a future-facing question, right? So where do you want to be in a year, and how do you see your Scala stack evolve? Where do you see your technology going? Let's make a prediction and come back in a year, see if it's true.
All right, so I'm taking a risk and making a prediction. Next year, we want to serve the biggest financial institutions here in the country, credit cards, banks, tech companies. In terms of our stack, we want to grow our Scala stack, get more of our machine learning and more of our algorithms be implemented in Scala. Right now, there's a lot of that happening in Python, and we are moving it slowly, productionizing more of them in Scala. We'll see more of that, and as our system gets more and more complicated, I'm really hopeful that we can release more open source projects out to the world, so there's more visibility of what we're doing.
That sounds like a great plan. So looking forward to this open source, contributing, collaborating, and TrueAccord.com, you can learn more about the company, Nadav, and the stack they're using. And I'm looking forward to your talk today.
Yeah, thank you.
Thanks a lot.